When it comes to hazmat response, speed and accuracy are everything.
You know what I'm going to say? Speed and power, baby.
Oh, yeah, speed and power, clucks and farm, but speed and accuracy, that's a 908 thing.
You guys know about the little black box, and now you have the little red boxes.
Yep, and these two boxes together are exactly why the world is trusting 908 devices. Their handheld MX908 and Explorer IR are changing the industry.
Right. That is the one of the few devices that can actually identify Novichoks.
Not only can it pick up Novichok, but it's also picking up all sorts of chemical warfare agents, as well as pharmaceutical-based agents, including drugs and explosives, and it's doing it, here's the key, at trace levels, which is unbelievable.
And I know the Explorer can identify and quantify over 5,000 gases and vapors in seconds, and that's going to change the game.
Yep, and so don't question us when we say that hazmat teams around the world are trusting 908 devices. Check them out for yourself at 908devices.com and upgrade your toolbox today. You know, it's not going to be long before Jake is telling people, his huge audience, about us. Because his new podcast, The Hazard Class, is absolutely exploding. So if you want to see just a great interview, great information, go check out Hazard Class podcast by our very own Jake Wright.
Dude, he did a rant on the Denver tool, and I was laughing out loud. I lolled.
You LOL'd yourself?
I LOL'd. I did. It was amazing.
No cap down low.
Yeah, exactly. Make sure you're joining us on the happy hour. You can only get there for your premium, and that is going to enter you for a chance to win a scholarship to the Southernmost Hazmat Conference, which is the happy hour is on the fourth Thursday of every month. The conference is February 3 through 5, 2026 in beautiful downtown Key West. So I want to come and see that one as well.
The newest thing to hit the THMG swag store is actually not swag at all, but it is our It would be a copy of the Nerds Book 2, which is a community-based training book. They are selling very fast. We're almost out of the hard copies that we have, and we might have some difficulty, keeping up with demand. So get them as quickly as you can.
Yeah, and some conferences, again, Central Virginia EMS in March, Wisconsin WAMR, that's in March, Oklahoma is in March, New England's in March, Michigan's in April, and then OMRA, and that's all we have on the calendar for right this second, but I know there's like 5 or 6 that are in the hopper right now, so things are moving along. They
are. In our last episode, we're detailing the different plastics that are out there. So if you are a plastic buff, like so many of us are, this is the information that you are going to listen to over and over and over again. It is extremely exciting.
Yeah. So we're going to get right into this one that we didn't mention in the first episode in those 7. This is one of those others. And it is UHMW, or ultra high molecular weight polyethylene. And this one is known for extreme toughness. It is a unique combination of abrasion resistance and chemical stability. It is really good for high friction environments and resistant to most chemicals. And its surface is also self-lubricating, which is nice. They usually use this in like liners and barriers and secondary containment vessels.
It's a little bit difficult to bond and weld, and it really does have limited applications out there. One place that you would absolutely want to use it is corrosive environments, right, or environments using corrosive chemicals that require high wear resistance because of that self-lubricating factor.
Now, it's okay with certain acids like hydrochloric, all concentrations, sulfuric up to 70, acetic acid, all concentrations, and phosphoric, which is a nice rounded out area of where we want.
Like so many other the plastics, it hits our basic bases, our sodium hydroxide, ammonia hydroxide, our potassium hydroxide.
All of our salts, aluminum chloride, calcium, potassium chloride, all of them.
Our alcohols are a check on this one as well.
and hydrogen peroxide up to 30%, water, and mineral oils.
Again, the pattern that we see over and over again: hydrocarbons, benzene, toluene, xylene.
Right.
No
halogenated
good,
solvents. This is, again, the solvents, the methylene chloride, the chloroform, the carbon tet, typically not going to. The only way I've seen these things is in like stainless steel casks.
This is why. I mean, they degrade other hydrocarbons, and plastics are other hydrocarbons.
Right.
You know, our ketones are the same thing. So many of our ketones are going to be dissolved by acetone or methyl ethyl ketone.
And things like nitric acid or oleum, which is fuming sulfuric acid, bromine, fluorine, those things you don't want to put in that.
So some of the dangerous stuff, like the, oh my God, I never want to do that, is going to be concentrated nitric acid, otherwise known as oleum. That can degrade the UHMW, if you're going by the parentheses, and absolute container failure or dangerous.
Bromines and fluorines, and those high temperature applications, because the chemical resistance decreases at elevated temperatures. And so a chemical that's safe at room temperature may be incompatible at higher temperature.
This is also a plastic that tends to degrade over time with compatible substances in it. Long-term storage can lead to stress cracks and degradations, or if it's put under any kind of stressful things, and our organic solvents can escape right through the container as it permeates by.
Another one is going to be your PTFE, or polytetrafluoroethylene. It is known as Teflon, which brings the question: if nothing sticks to Teflon, how do they get Teflon to stick to the pan? Right?
They lick the back of it.
Right. It is the gold standard for chemical resistance. It handles extreme temperatures, right? It's why it's on a pan that you're cooking with, and virtually all chemicals. It's a non-stick surface, ensures easy cleanup. It is usually used in like gaskets and seals and linings for highly reactive substances.
But it is costly, so we don't see it around that often, and it doesn't really have the same impact protection that HDPE or polypropylene is going to. So they reserve the polytetrafluoroethylene for extreme situations where you really need that unparalleled resistance, and you can justify the expense.
Now, it does well with acids, hydrochloric, all concentrations, sulfuric up to 70, acetic, all concentration, phosphoric, all concentrations.
Yep, the bases, same thing, sodium hydroxide, aluminum hydroxide, potassium hydroxide. We're pretty much seeing very similar things to all the other plastics.
Good on all your solvents, right? It's good on acetone, chloroform, ethanol, methanol.
So this is kind of a reverse, right? We often saw these as incompatibilities for other plastics. It's great with hydrogen peroxide, and hey, it can do well with benzene, toluene, and xylene. So if that's the chemical that you're looking for, this plastic may be what you're looking for to overpack it.
What about things it can't do? Alkali metals like molten or dissolved sodium, molten or dissolved potassium, or molten or dissolved lithium.
It doesn't work so great with fluorinating agents, right? Your xenon difluoride, cobalt difluoride, chlorine trifluoride. This is a reverse to just the general halogenated hydrocarbons that we see in other plastics.
And it's no bueno with fluorine gas. Even at high temperatures and pressures, not a good thing. And
now,
oxidizers.
And oxidizers. Dangerous compatibilities, right? So what is it not compatible for? Although it is safe and inert with a lot of things, we have to be aware of things like the give me a second. Alkaline metals in molten or dissolved alkaline metal form, they can attack the PTFE, potentially leading to rapid degradation and failure of the material.
Right. So anything that's a fluorinating agent, it's very reactive. It's violently reactive, and it's even worse at high temperatures and pressures. And then even finely divided metal powders. So those intimate blends of finely divided metal powders like aluminum or magnesium with powdered PTFE can violently react when ignited. And though the ignition temperature is far above the maximum service temperature, it's still a concern.
We have heard a lot about Teflon pans and, hey, we can't do them at super high temperatures. When we're cooking, anything above 400 degrees on the stove we would consider like a pretty high temperature. So we see that reflected in the thermal decomposition and high temperature applications with this type of plastic. At 260 degrees Celsius, PTFE can actually start to decompose, releasing really toxic fluorinated compounds. This is really dangerous if we're looking at enclosed spaces or poorly ventilated areas.
Hey, Mike, take a look around you and tell me how many lithium-ion batteries you have around you right now.
Oh, I got about 5 or 6 right here on the desk.
Exactly. Batteries are everywhere, and every department in this nation is starting to deal with battery fires on a regular basis. And we're excited to tell you that a new product that mitigates battery fires on the go is from DeGeo, and this product is a game changer.
DeGeo is the newest packing division of Label Master, and their new team, they get it. They have been in the hazmat industry for over 60 years, and I bet you don't even realize that you've seen their placards and labels in your house from your online order.
They have dropped a new granular product called ObexionFR, which will solve your insulated battery needs. And we can say this product actually lives up to the hype because we've tested it firsthand. Most importantly, the product is proven to reduce the toxic gases emitted when a battery kicks off. So to learn more, go to ObexionFR.com. That's ObexionFR.com. Now, you know what? It's another thing I hate.
Getting certain body parts caught in a zipper?
I hate my face burning off.
Oh, that's pretty, honestly, those two things are pretty close, but what the heck happened that your face is burning off?
Well, from radiation, or actually not knowing about radiation being around me.
Oh, well, that's pretty valid, but it's a good thing that we've been playing with the new meters from Mirion because they are top shelf devices.
Yeah, I'm going to bet a bunch of you don't even know who Mirion is. And it's not a girl I used to date. I didn't even know who it was until we actually started talking to them. And wow, like there is more than meets the eye with these guys.
Yeah, we looked them up. They are a multi-billion-dollar company. We had absolutely no idea how much they reached into the medical, nuclear, safety, and defense sectors.
Yeah, and so for first responders, they've got some really cool tech like the AccuRad, the Spear Ace, the Spear View. That will help you detect and monitor radiation quickly and accurately so that you can make smart decisions on the fly.
Check them out at Mirion.com. That's Mirion.com.
Let's get on to the number 6 on our list. PET. That's it. Polyethylene terephthalate. PET is commonly associated with the consumer application, but has some niche uses in hazmat response, like it's transparent and resistant to weaker acids and bases. It's also lightweight and recyclable, right? And is that my house? Where is that? Emergency water storage and non-aggressive chemical transport.
So as a result, it's not really suitable for strong acids, high temperatures, or prolonged UV exposure. Using PET for short-term storage of low-risk materials, that's a good idea. Anything else, I would be like, nope, not going to happen.
Right. It's good for hydrochloric acid up to 30%, so dilute sulfuric acid, acetic acid, good for your vinegar, excellent. Phosphoric acid, up to 85%.
Bases, we start to see a limiting in what it's compatible with the bases, ammonium hydroxide, right? But we do see all the check marks for the alcohols, your ethanol, methanol, isopropyls.
And it's also good for hydrogen peroxide up to 30%, mineral oils, silicone oils. It'll go good for that.
Now, incompatibility, right? We said it was good for weak stuff. The strong bases, we start to see it fail with sodium hydroxide at 6 molar and potassium hydroxide.
Not good for the solvents. Your ketones, like your acetone, methyl ethyl ketone, chloroform, tet.
Your nitric acids, right, and your sulfuric acids high, no good.
Right. And now we have some dangerous compatibilities. When PET is generally safe for chemicals, there are some potentially bad ones like concentrated nitric acid, sulfuric acid. Those will degrade it, potentially leading to container failure or leaks.
Our alkalides are going to affect this material and cause rapid degradation, especially when we start to see high temperatures and or high concentrations.
Right. And you can have your organic solvents once again.
High temperatures, like all of our other plastics, right? I can't get across how much high temperature affects the plastic's chemical compatibility. Long-term storage, we're good short-term, but as we start to get long-term, we see stress cracks and degradation over extended periods of time.
Now, another one that we might run across is PVDF, which is polyvinyl diene or fluoride. Sorry. This offers a little bit of a balance between the chemical resistance and mechanical properties, making it a premium option in hazmat. This is resistant to a wide range of aggressive chemicals, including halogens, strong acids. It has good thermal stability. Usually you'll see it in like piping systems, tank linings, chemical storage units in high purity environments, more the industrial side.
But it is a high cost compared to HDPE or PVC. When using PVDF, you want to, especially when you're handling high corrosives or highly pure substances that require a durable container, the PVDP is going to be where you want to go. So high concentration and high purity substances.
Right. Now it's good for your acids, your hydrochloric, all concentrations, sulfuric, phosphoric acid up to 85%, nitric acid to 50%. It's pretty good across that.
Your bases, thumbs up with some of them, like ammonium hydroxide and sodium hydroxide.
You got your halogens, which is the chlorine, bromine, iodine, organic compounds like alcohol, methanol, ethanol, propanol, aliphatic hydrocarbons all work.
You're good with your hydrogen peroxide, and you're good with most salt solutions. So what are some of the things that this is not compatible with? Well, our super strong bases, it's not going to work well. So if you've got a 50% of sodium hydroxide or concentrated potassium hydroxide, you may want to jump to a different plastic.
Once again, the organic solvents like your ketones, your acetone, mech, chloroform, carbon tet.
Right. Fuming sulfuric acid, fluorinated gases at high temperatures are going to be no good. What are some of the absolute dangerous conditions for here? Well, there's going to be very similar to a few of the other ones.
Yeah, actually, yeah, it's going to be like your molten. I wouldn't, I don't understand why they're even saying molten in these things. Why would I put molten? Like, I'm thinking like lava. Like,
right, like that's what I did. Like nothing like withstands molten temperatures. Like, why is that like the big, hey, like, who's holding a container of plastic being like, see that red hot stuff right there? I'm going to put that in here.
Yeah, that's, I don't know. And yeah, so you got to watch out for the hot stuff.
Right. What about, is there anything with any of the alkalide metals with this one?
There is molten or dissolved sodium, potassium, lithium, and chemically attack that, potentially causing some failure.
Our fluorinated agents can absolutely start to degrade the PVDF, especially at high temperatures and pressures.
Which high temperatures is the problem, because a chemical that's safe at room temperature might be incompatible at high.
And we know that at 260 degrees Celsius, PVDP can begin to decompose, releasing, again, these fluorinated compounds that are really, really dangerous.
Let's take a couple seconds to talk about some case studies on this. Right? So let's say we have an incident 1, right? And it's going to be an acid spill containment gone wrong. So we'll say that a team used a polypropylene container to store concentrated sulfuric acid during a spill. And then within minutes, the container deformed due to the exothermic heat generated by the acid's reaction with the plastic. And that led to a secondary containment failure and a much larger spill.
So what do we have to do? Well, as a resource operator, we have to understand the chemical reactivity as well as the heat generated before using a specific plastic. There is 2 things that we have to look at when we're trying to figure out a container. One, obviously, it's the chemical compatibility with that plastic, but because all plastics are really crappy with heat, we have to make sure that that's super clean. Because if we have a chemical reaction that takes place that has nothing to do with the plastic and it heats up on the surface of the plastic, we can warp and weaken the plastic due to its high temperatures. Incident 2, right? A solvent breach in a PVC type 1 container. A misstep occurred while a solvent storage team used a PVC Type 1 tank for a highly polar organic solvent. This solvent permeated the plastic and led to a slow but eventual catastrophic.
So again, check your compatibility charts. Once again, get the compatibility chart that we give to you, because you have some best practices you can do with your plastic selection. You want to assess the chemicals compatibility using those compatibility charts and consider factors like concentration, temperature, and exposure time. And before anybody says, well, how the hell am I supposed to know what plastic I have? Look at the triangle, look at the number in the middle. That's the type. And all you got to do is put it into the old Googler and say, I have a plastic number 4. And it'll say, it's plastic X. Then you go and you check your chemical compatibility, and there you go.
You could also possibly run some of these on your laser meters, like your FTIR and your Raman. Just make sure that the focus of the Raman is on the plastic and not through the plastic, because some of these Ramans are able to see through the plastic. We want to prioritize durability. We want to opt for plastics with high impact and abrasion resistance for transporting and handling. So make sure that the physical characteristics of the plastic that you're dealing with, they coincide with what we're looking for in what we need out of the overpack container.
And consider your temperature. As we said in all these things, is that if you have a product that is hot or will be hot for a certain amount of time, we have to watch out for that, because the thermal environment is going to actually do something to the tank.
And you heard us now for 2 episodes ramble on about a chemical and what it is compatible with and what it's not. And while some of them were exactly the same, and you may be sitting there going, oh my God, they're repeating the same information. If you really listen to what we were saying, we were not repeating the same information. There were small differences with each one of them. Not all acids, bases, and solvents behave the same or in a precise manner. And some of the best ways to understand the difference between those two is training. So get ready to train differently. Head to thehazmatguys.com, book your custom training today, pick up a copy of your nerd book, browse our exclusive swag, get your department added to our grant funding list, stay on top of all things Hazmat Guys. Don't wait, secure your spot today.